Yes,
Now I'll
I'm the
turn it
big
over.
boss. So thank you.
Oh, you don't need that.
No, I don't need that.
No, you don't need that.
Oh, so thanks for the introduction. I thought it was only a problem of Spanish speakers to have, let's say, weird relationship with my surname, but I see that is also from other countries. It's Sollazzo, the name. But I'm here to represent a series of designers. I'm here because we are the organizer from Numina in collaboration with USTRY of this project that is called Reshape, and it's a distributed frame of research for us. It's actually a competition that we open up to a series of designers to participate with us in understanding the application and implications of innovation regarding very specific topics. We will have actually, after this talk, another roundtable with more or less the same people, but talking about the Reshape. So let's bring everyone back and let's discuss a little bit about what we just saw in this very informative panel. So please, guys, take your seat.
I guess we get the couch.
Yeah.
Okay. I can sit here or I just can sit here. Someone is missing, I guess, right? Yeah, probably Francisca is missing. Well, I can sit here in the meanwhile, so I'm not too far away from you. I mean, I was just wondering, looking at your presentation, what people was thinking. Because, I mean, they were here to look at a presentation about fashion and retail, and then suddenly you were talking about agriculture and sustainability. And I'm wondering if they understand which is the level of connection that we have in this very specific topic. Cecilia is used to open their presentation talking about the fashion industry as one of the most polluted one. So I mean, how what we just saw can be closing the gap of this implication that the fashion industry has with the environment. So how can we apply what we saw, you know, not to produce only food, but also to produce our clothes?
Yeah. Thank you for the question. Well, I was actually kind of I showed the last slide the thing that we did with growing bacteria to try to make semiconductors. Also like a wet lab, we did it in La Paillasse, which you probably know in Paris because we don't have a wet lab. And I saw you doing the same types of things in WAC, trying to use bacteria to write pigments. And this is, I think, this is closely related. It is trying to see how you can use natural processes to make material, or use natural processes to degrade material and reuse it. And I think this is a very important aspect. So whether you use it to make textiles, which I think could be is very interesting, like with kombucha and so experimenting with that, and or try to make it for food. I think those processes, trying to use these natural processes, is really a challenge, I think, and it's a great challenge. So I think that's a connection between some of the things that I presented and some of the things that Cecilia presented.
Yeah, absolutely agree. I think that actually, well, I think I'm good with this. I think the funny thing is that we've been slowly realizing, way too slowly, that actually everything, the way we've been working is so unsustainable. And in the 60s, we had this whole revolution where, especially with dyeing, we went to fully synthetic dyes, but we were using natural dyes until the day before. And those are actually strictly connected to agriculture. But on the other hand, bacteria, somehow too. I mean, we're growing the bacteria. Growing your clothes, growing kombucha, growing fibers, all of it is strictly connected. And it's much more about searching how in different disciplines we're tackling the issues and how we can bring it together to solve issues for other industry. It's like a fab lab. You have a machine and it's meant for something, and then you use it for something else. You're solving an issue for a different industry. It's the magic of technology.
I would like to know also the position of the others about this topic of sustainability and the fashion industry. If there is any, I mean, it's kind of an open question. I mean, very open, wide question. But, I mean, do you see feasible that you will be 3D printing or fabricating shoes that is grown in the courtyard of Adidas someday? Is it possible? It's something you are thinking about, you know?
Yes.
Yeah.
Yes. Give us enough time and money. Yes, but there are things in this realm which are not so far in the future. You mentioned some of them. There's certain aspects of growth or biological processes that would drive us in that direction. Not that I can speak about it in detail, but anybody that follows these things and can read between the lines can picture their own, you know, way of looking at these things. There's also an aspect of, even in the pure relocating of manufacturing closer to the destination of the goods. That alone is a thing that's happening now. That drives a reduction of waste because time tends to drive inefficiencies, and therefore you make a lot of shoes that you actually end up throwing away. That's one thing. Number two, the processes therein tend to be more economical because you're not cutting and throwing away. Just knitting per se tends to have a far higher efficiency than cut and sew. So some of the things are almost there. Some of the things are further out in the future. I think the almost there is anything that's related to better manufacturing processes, which is also nicely tied to the fact that the incentives in the business drive you in that direction. It makes it so that not only it's good, but it's also necessary or convenient. So the answer is yes.
Looking forward. Okay, you know, I saw some kinds of connection between your presentation. And this was actually one of those, no? Between Cecilia and Peter. But I also, I was listening to Simone and Francisca before, and you were both very focused on this idea of performance, no? Through material studies. Actually, Simone was also talking about data-driven decisions that can somehow trigger through fabrication this kind, let's say, that can close the gap. How much performative is the product through digital fabrication. But both, at the end, you have to, if you just, let's say, if you design something that is performative, then you also have to have a tool that tells you that is how much is performative. So it becomes kind of a loop, right? Where you have design, fabrication, then you look at performance that you have to evaluate, and then this evaluation goes back to your design operation. So, but how much time does it require in a big industry, no? In a big company? All this loop sounds a bit more complicated, no? Or sounds a loop that requires time. And now with these tools, you are closing the gap that allows this operation to be done in your company.
Yes, I think at the moment we are not in that position that we are fast enough to do that. We have to learn. We have to check the possibilities and also go more deeply in simulation. So modeling and simulation, I think, is a big point where we have to focus in the future in that topic. But until now, of course, we are not fast enough, but we have to do those loops, and we have also to try to find the manufacturer of the systems to get more quality control, quality monitoring in the systems, that we can reduce those loops and get better quality out of the machines.
In terms of speed, I'm kind of more optimistic than you are in terms of loops of speed. What I'm really curious about is, and I don't know, I don't have an answer, is how much is a consumer going to be willing to wait? Because even in the, we have had explicit experiments in which we made to measure, and you still had to wait a few hours. And I think a lot of the challenge there is to understand how much are we impulsive animals that need to get it now, especially teenagers. That's an important segment for us. They tend to have very quick reaction times between seeing and wanting. And then the other aspect is how much of that will turn into a completely different business in which you're actually not selling the goods, you're potentially selling more of the experience around it. Because, in the luxury segments, for example, it's really interesting how they turn the process of waiting and getting measured into the whole thing. I've happened to go through one of those. I ended up not buying the product. But honestly, I would have paid more than a pair of shoes to just go through the wonderful process of getting measured. And that might be another way of abating the problem with the waiting time.
Yeah.
I don't know if
It's an
I don't know if
interesting.
it's just me.
I mean, also opens up this idea of a customizable object, right? Now, where you are not only designing which is the color of the shoes, but you are also part of the entire process that generates the shoe itself.
Yeah. The other benefit in that is the fidelization of a customer. Because once you've gone through that process, there's a higher incentive for the customer to come back because you know them. So it ties you more tightly to them. And that's an important aspect because acquiring a customer is much more expensive than keeping one. And it's an interesting aspect as well.
You want to add something, Paul, about that?
No.
Paul, here the connection was also again clear, probably with the work that Grace was doing. Actually, I didn't know this part of your work, and it was extremely informative to see your presentation. And you were talking, I have several questions, but you started with, I want to do it, then I can do it, I can make it. And then suddenly you were also talking about machine learning, right? So it's the machine that makes it. And in this case, in this project that you were showcasing a little bit, what's the gap or what's the role of the machine and the designer? How they contribute to end up with a final product? No? Who is the designing it, and who is designing what? Let's say, in this case.
So to that end, Autodesk is typically kind of considered a CAD company, although we're arguably like moving ourselves into a position of a company that helps people make stuff. And when you talk about CAD and then AI, you can make an argument that computer-aided design is not what CAD stands for. Today, it's computer-aided documentation. Like where I click is you do exactly what I tell you to do. Now, what AI does is actually make it computer-aided design. So I'm in the process of designing something, and artificial intelligence is not taking over, and machine learning is absolutely not taking over, but it's helping to expedite that process and make calculations and design decisions that you can't do in that same process. So this is the promise of generative design. Products like Dreamcatcher allow us to take mechanical engineering problems and rather than spend loads of time iterating out hundreds and thousands of solutions, get the machine to take over that based on the inputs and variables we want. And so that's where the value lies. There is absolutely no way of replacing a designer or an engineer right now. Maybe 20 years from now, that's why I'm trying to learn how to program. My job title probably has a shelf life on it. But that's really where AI sits today, and that's where it's most useful.
Yeah, but talking about now, we jump to the reshape, no, and to the prosthetics. And let's keep the topic on AI. There is one project that the guys developed. It's about a spine that somehow is learning from the body through an AI system how to correct the posture of the body itself. So, I mean, it's kind of interesting that probably the design process is not embedded, but the reaction, the interactive part is actually the one that is triggering then the very feasibility, the very functionality of the element itself. So, I mean, I see that there is a gap in there where we can actually start to leave some part of the process to the AI, and somehow insert this AI into our system, into our product. And how close are we into if we talk about prosthetics, do you see it feasible, this project that is there, it's just still a dream, or do you think it can contribute as well to understand how to interpret the forces that are acting on the body and somehow trigger a reaction, that can somehow give a solution to the very specific problematic?
Yeah, I think I could address that. For sure, if you're going to do any type of medical-related or health-related garment, or I think something close to the body, hopefully you have a doctor or a therapist on the team. But if you do not, I feel AI and machine learning can be really complementary tools, same as what we've looked into motion tracking to better inform designers to make quicker decisions. So for example, at TextileLab, we looked into motion tracking to better iterate quickly how to pattern cut instead of doing it more than 20 times to get it right as a fit. So that experience was shortened, but I think the quality of that experience is what I think we were mentioning before, has definitely retained. So it's more about telling that individualized customer and customized story, but also making it a universal application. So actually all of our pieces at OpenStyleLab are universally applied. So a girl with autism could wear the same thing as a girl who does not, as well as someone who may have cerebral palsy. So in that way, companies are able to target a market that is, in my opinion, untapped, predominantly maybe held by healthcare. So then we can look into the marginalized global, I think, trillion economy of people who have injury that don't have enough healthcare in the United States. Maybe not so much in Europe, because you guys have such great benefits. But there could be, I think, really great ways for AI and machine learning to kind of advocate future design roles.
But again, Grace, I mean, you were talking about accessibility and innovation, and then, you know, the connection here was education. And I mean, how important is education today in the field of innovation? How much it triggers some project and research that we see ending up in products that big companies somehow can make theirs. No?
Yeah,
So
I mean, you see it all over the news, right? There's this kind of fear that AI might take over certain jobs, as well as seeing what does the future of education look like today. A lot of companies that you guys are representing, I am hoping that the students are being prepared to be able to meet you halfway. And that means A, catching up to the technologies, but B, also having the space to conceptualize creatively, not having something so systematic or structured. So if you're gonna have a tool like Node.js that's gonna capture data or have Bluetooth or Wi-Fi, do you know why they can be used in a creative way that I think is not always for additive manufacturing or for the advancement of technology, but really about what do we want as a consumer? What kind of products and services are we looking for? And I feel that we try not to kill the creativity for our students. So any company that comes to us, they're like, we're here to recruit for like new AI position for a designer or the next UX designer role, we're like, okay, what does that really mean? And how do we have 15 weeks in a semester to prepare these students?
No, I'm, you know, one of the things that they keep saying about AI and neural networks that is a fundamental problem is, and I find it funny and interesting to think about, but one of the things that you keep reading about is the fact that nobody knows why the response came out that way. You know, all these
box.
artificial intelligence systems, you feed them impulses, they give you a solution, but nobody can still tell how they came to that solution, and you can reverse engineering. And I find it extremely funny that that is exactly the description of a normal design process. You feed the designer a lot of input, something comes out of the other end, and you don't know what's going on inside their heads anyway. I find it interesting. What I find in this context as something really stimulating to look at is how a lot of this move to virtual tools and to different manufacturing processes has actually sort of disintermediated the relationships between the actors in this. If you look back at 20 years, pre-internet, pre-additive manufacturing, pre-diffusion of CAD tools and so on, you would have no chance of doing the things that you were showing before, getting very diverse groups of people together to do something completely new. Because it would be hard to find, they would be secluded, they would not have access to communication tools and so on. This is what I find really fascinating on how it lowers the threshold to get to know people that might have the same problems that you do, get to talk to them, figure out what the real problem, assemble a team that didn't exist before, and still be able to produce something. Back in the days, these would all be impossible problems to solve. These days, they are no problems. If I talk about these things to my kid, they go, duh. What's a, I have to tell them that I had to go buy records in different places. They go, what, you didn't have Spotify back then? No. But this type of thing is happening to manufacturing and to idea generation. And I don't think any machine can do the job of 5 different people getting together yet. As he says, it still worries me to death.
Yeah, I totally agree. I think more the younger generation today have an overabundance of things. So they either get distracted from Instagram to like the latest library, or something's always happening that's a new tool. And to be able to soak that in, I feel is getting a lot harder than previous generations, where we're like, okay, we'll just do this slowly and it's okay, but we'll figure it out and it'll process.
I think we're starting to sound a bit old with that statement. That's I mean, the tools that new generations are using, it's the same argument of like, well, I learned at architecture school to use a drafting table, and then I go into and then from there translated into CAD and was using AutoCAD, and if I go into an architect's practice and like, well, it's not as good as the old days. Like, things have evolved, and so the tools evolve, and the way that we approach problems has evolved too. And so the argument, to some degree, becomes a little bit redundant, because we're simply trying to reframe problems the way that we understand them, and not the way that a digital native understands them. So Generation Z has grown up with all of these permeations in the technologies around them, and yeah, the distractions that come with them. But that's the same thing that my granddad said to my dad about, oh, you damn kids and your TV. Or now it's your damn kids and your phones. It's just the same. It's the same complaints or problem statements, just updated for 2017. I don't necessarily see it as a concern. In the internship programs and the students that we work with, of course, there is always a discussion of like, learn to code. It's one of the most valuable skills you're going to be able to have. To interact with the artificial intelligence, and the statements you made about, you feed the problem into the designer and output comes the solution. It's kind of funny that we're obsessed with figuring out how the AI did it. It doesn't matter, it's machine logic. We're human beings, they're machines. We created them, we planted a seed, and then out comes the result of that. Does it really matter that much how they got to that solution?
I think the difference, I know that you guys, I'm the moderator, I shouldn't express any opinion, but I guess. But probably the difference is how the structure of our learning process, no? It's a distributed one. Probably before we just learn, through a system that was way more structured and recognizable, while now it's more spread. And during the path from one thing that I'm learning and the other, there are more possibilities to catch up with things that we weren't expecting. So it's a more, I would say, a more flexible process that allows people to move between different disciplines. But I wanted to make a boring question. So you were talking about licensing, right? Or I can say licensing in Italian accent. And you were talking about licensing as something that somehow is limiting the ability to bring into the market some of the innovative products that you are experimenting on. But how big is the gap? Because here we have a lot of gaps in general. We have gaps between things that we are learning, that between different professions that are starting to embed, but there is still this kind of system that starts to be a bit too slow. Again, it's a matter of time, no? Again. But how difficult is it? And how is affecting the ability of a company to produce innovation?
So for us, I think it was 4 years ago that we decided to being a part of a development, or more or less a development partner for such a machine which could improve our production in additive manufacturing. And we decided, okay, this will be not very easy. We will not get a finished system which produces what we want. But when we look on the market, there is nothing available what fulfill all our criteria. So now we can, on the one hand, we can decide, okay, we are waiting until there is a system available which is doing what we want. And on the other hand, we can create our own machine or try to improve together with the manufacturers. And then we decided to go the development way because yeah, we have to be one step ahead our competitors, and this is the easiest way to improve and the easiest way to be one step ahead of all competitors. Yeah.
Okay, thank you. Peter, I think we have time for the last question. I mean, we're gonna work together now. We're gonna work together for a project. It's called ROMI, Robots in Microfarming, and it's gonna be an interesting project where we have to somehow come up with a system, a robotic system that allow us to integrate the knowledge of the farmer. So it's basically it's a system that builds up innovation over the traditional know-how, and it's something that you were also mentioning before. How difficult it is to do that? How much we're gonna suffer and struggle to actually achieve a balance between these two different aspects, no?
Okay, yeah, I think there's still a wide gap between, say, traditional knowledge and then trying to bring this to some more machine level. Mm-hmm. And to be honest, I have no idea.
Yeah, I was care about that.
But give me a second there, and I'll come up with a good idea.
Well, I mean,
there is things that we could try to do. I mean, probably the sort of intermediate step will be language, right? And we have some tools in the lab. We have a research group on language, and that is trying to is basically, this is the work from the founder of our lab, Luke Steels, where robots try to acquire language by being in a shared space and trying to explain to each other what they see, and gradually grow a dictionary, shared dictionary. When they look at events, they gradually introduce a grammar to explain the events that they see, a grammar to express like the spatial relations, for example, before, behind, left, right, etc. And now you trying to couple that to sort of low-level observations that you could have from in the field, and linking that to robots explaining to each other what they see, and then linking that to, say, human operators that try to communicate with those robots, also providing input from their observations, or robots asking back questions about, okay, I don't understand this, can you give me an indication? You told me to pick carrots, I have no idea what carrots is, can you show me in this picture what it is? Mm-hmm. So, I mean, there's a lot of layers there, but I mean, and then the top layer of there is having all this knowledge from a field that exists, and my colleague already started to look at old farming manuals on trying, recovering them, translating them into this computer readable text, and then mining them for terms and that have been used in the past that we no longer use, to see how these texts have evolved. But getting that into a system where it's usable by robots, there's still like a lot of steps to take, but sure. It's definitely one of the challenges I think that will be interesting to look into.
Yeah. Okay, 0-0, perfectly in time. So I want to thank everyone, also first of all the speakers, for participating in this panel.
I have a chance to ask one question.
And I have the chance to ask one question from the audience. So if you want to
ask a question, please raise your hand and direct it to one of the speakers or to the panel as a whole. Does anybody have a question they'd like to address to such an expert panel of speakers? Don't be shy. Don't go home tonight and say, man, I wish I would have asked. Okay? No? Yeah, maybe? Maybe have a microphone. Wonderful. Yes.
So I needed a little bit more time to frame better my question, so I take a breath. No. There is this issue happening in implementing digital technologies and eliminating the human factor that is not necessarily bad, because human creativity can be manifested in digital tools and not by hand. But there is, finally we end up being monitoring the machines. And this is a waiting time. So we program and we design the machines to do something, but we still need to be there physically to monitor them. And do you think that the artificial intelligence could, or like some kind of other monitoring system could improve this flaw? Because the human, finally there are humans behind the machines, like watching them. Is it clear, my question?
Who would like to take that? Paul.
So I think what you're touching on there, when it comes to autonomous systems, is the process by which we teach AI. Up until recently has been a kind of real-time process of, I need you to do X, and then it just does that. But what we've started to do is actually pull that scenario or that environment. If you think about a robot in a factory that has to perform the same function 1,000 times over, rather than having it do that in real time, we've developed virtual environments to teach it and to get it to understand its surroundings, so we can learn that process as well as that kind of self-regulation in machine time. So the speed at which we think things is typically pretty instantaneous. But when we try to give that to robots and do that in the real world, it doesn't make any sense. So what we can do now is get it to learn in its own virtual environment, where it can use its own processing speeds and go through that whole series of scenarios that it might be faced with. So again, if we use the robot in a factory of like, please don't hit a human being because they're squishy and they don't like getting smashed. You can put these scenarios into a virtual environment, teach it to do that, and then sort of implant a sense of ethics if you want to take that as a particular scenario. And then it knows how to do that in a matter of seconds, and therefore it becomes a truly autonomous process that you then don't have to monitor anymore. Again, sensors sort of help with that, and the promise of IoT helps to remove that human element if that's what you want.
Well, I want to just move a little bit out of the machine learning. Sorry, I know that the panel was over, but there is already intelligence, or we can embed intelligence into materials as well, into bacteria, for instance, as well. I mean, and we have people that are exploring already how to probably adapt or use a living system in order to somehow be the intelligent layer over the body that can possibly, again, in a research and in a futuristic way, can possibly be converted into a new sense of garment, right? And this is probably what you are also exploring in your practice.
We are exploring much more of a collaboration, I think, with the living, with the organisms. And on the other side, we are studying them, we are analyzing them, we're trying to learn from them, because we're learning from them. It's a microorganism, we can't even see them, but we're learning from them. The way they produce color and pigments, and the way kombucha grows has been cellulose. It's super interesting. It completely changes the way we look at materials. But on the other hand, it's learning and taking and giving, and it's implementing them. But it's hard if you're not a microbiologist, if you're not a chemist. So again, for me, it's about collaboration. It's about opening up the little bits of knowledge to be able to implement it, and then find worldwide all of those people that can make this happen. And this is also why we were talking earlier about like the young generations and how they're on their phones. Well, they are the ones that make this possible. They're sharing 24/7 crazy stuff, how to do everything. They have no problem with sharing. And we're still so much stuck in this world where we cannot share because otherwise somebody else might steal our idea. And they don't have it, they have it, but we are putting it into their heads. So the world is taking many different shapes through technology, through advancements. I mean, what things you were talking about, I'm like, aha, I want to know more. And it's like when I entered in the biolab, it was the same. It's like, I want to know more. It's like, how does this work? How can this impact my work? But the way they look at it and the living organisms maybe looks at us too, and we look at them. It's all relationships that are truly changing, I think. The outcomes, the way we learn, the way we do things.
Thank you.
Okay, very good. Round of applause for our panel, please. Very interesting topic. Thank you very much for asking your question. I think you maybe have room for a little bit more discussion. Thank you all very much. You all will be returning very shortly.
With the awards, the Reshape Awards.
Yes, you're going to give the awards here, right? On this very
on
same
the stage.
On the stage at 6 o'clock?
6 o'clock, we have the Reshape Awards, and I'll see you there.
Okay, at 6 o'clock, Aldo will be giving out the awards, and most of all, we'll find out who the winner is, okay? So at 6 o'clock, in other words, we have a brief break, but please come back so we can give the winners of the Reshape Awards a nice round of applause for their work and find out what it is. Okay, we'll be back.